those patterns transforming into anti-patterns. When I'm saying services, everyone starts thinking about microservices, and everyone is hyping to learn something new about microservices. Maybe it could be disappointment for you, but I'm not going to talk about microservices exactly, but just about services in general. So, a little bit about myself. I'm going to talk about quite obvious things, so today I'm going to be your Captain Obvious. Please don't hit me if you already knew what I'm talking about. So, during my career, I kind of found some patterns how people are using their own services or other companies or other organizations' services. So, and this is not about design patterns or something else. It's just natural patterns which are rising when systems are evolving. So, and the main reason of those patterns that people do not think when they are building those systems, they do not think how they will use those services, how those services would survive this usage, and so on. Most obvious pattern is when you have service A and service B, and for some entity in service A, you're calling service B. Everything works just fine until you using something like this. It's unfortunately no syntax is highlighted on this projector. So yeah, you got list of entities. So you're calling service B multiple times. And this pattern, I call it machine gun. Yeah. Just like a guy with a machine gun, you just have a target and you started to shoot all your requests. And the same as a machine gun, you kill this service with maybe not the first bullet, but after a few hundred of bullets, you're killing this service. Second service, like, you know, we all are smart people, we know Java 8, so we are thinking, maybe we could do it a little bit differently. Maybe we could throw those requests in parallel. So, and this I call a Gatling machine gun, when you got multiple barrels and each barrel is shooting. Sometimes it works. For instance, it worked for me when I was uploading files to Amazon S3. So it was kind of capable to handle this load. But when it comes to your own services, you might kill it even faster. And, okay, we'll talk about it later. You're not only killing service B, but you also might kill service A, because you got, in this code, you are using default thread pool. So if you got some problems with service B, then some requests in this pool will be hanging, and you might flood this pool completely. So, but again, we are smart people. We think maybe we shouldn't call service B for each entity. Maybe we should just throw the list of entities, entity IDs, and do some work there and get the result of that. This is a kind of batch call, yeah. So, and it's much harder to kill service with this one, but there are some other problems with this. So, and the third or fourth pattern is a stealth working. When you're thinking that maybe this batch call could be made in the background, triggered by some scheduler or something like this, so nobody would notice this load. It will be hidden from everyone, and users magically will get the updated data in the system and so on and so on. It could work like this, but there are some problems, usually. And those problems are arising because we got some ideas how our services should work, and usually those ideas are not true. And false beliefs called fallacies. So this part I call interaction fallacies. So in 1994 there were figured out some fallacies of distributed computing, like false beliefs about our network and the systems which working over network and so on. And I think at least half of them are pretty actual for us today when we are dealing with some network stuff. But also, I think that half of them could be rephrased into something related to services. That we think that service is available, and that we think that response would be instant, that bandwidth is infinite, that no errors could happen, and so on. So, and when we are thinking that service is always available, we making ourselves we are making really bad assumptions, because for instance, if we are going to penetrate this service with a machine gun or with Gatling machine gun, what are we going to achieve? If this service is not available, the first and most obvious consequence of it, we will have a read timeout. If we are talking about HTTP services, any kind of, we are going to have a read timeout, and if we have hundreds of entities we need to call the service for, we will have 100 read timeouts. That is not very convenient, because default the read timeout, I guess, it's 10 seconds, so we have to wait. Your program will have to wait 1,000 seconds for 100 elements. So we have to do something about it, and I will talk about it later. Another fallacy is that the service will respond in a timely manner. For instance, in my previous organization, currently I'm working for one of our sponsors, Citycom, but in my previous organization there were a service which was receiving a bunch of IDs, and it worked just fine until some moment when the database query became so slow that the service wasn't able to respond in a timely manner, and it was working correctly, but we didn't get the result of this work. And believe that amount of calls is manageable is also kind of tricky one. For instance, in 2010, we were making a service for file upload for Russian insurance company, and when we're talking about the amount of files they want to upload, they told in old system users were allowed to upload 5 files. So we estimated that maybe they would want to upload like 3 times more, 15 files. But what was happening? It was system for processing cases, insurance cases for Casco insurance. So when your car got hit, you have to make a couple of photos and then send it to insurance company. But probably because of some adrenaline rush after this accident, people start making hundreds of photos and they were uploading them all. So, fortunately, when we did the pilot run with this product, we faced it immediately, and we kind of optimized our system to be able to handle 100 files. But what if this would happen like on the 3rd month when the system would be widely adopted and so on? So, and of course, fallacy of services is that we believe that our calls will be served properly. We will get some response. I've seen some services made like a couple of years ago. They were checking only 200 response code for HTTP and nothing else. And if something goes wrong, they just would fail, even if it could be like 201. So, what can we do about it? What are our instruments? I'm not going to list you a bunch of technologies like Alexis did. Since I'm not a developer, I'm a software architect, I'm going to talk about the concepts. Just kidding, I'm writing those. But when we're talking about services, we should, before we create service, we should think how this service should work. What do we expect from it, and so on. So our choices are quite trivial. So we need to think about caching policies. What could be cached? How long we could hold something in cache, and so on. And we should think about it beforehand, because we might want to split some entities into something static, which could be cached, and something volatile, which changes which could be changed any moment. So we should make our calls only for volatile parts, and so on. We should define a limitation, like in my example with this file upload stuff. If we could say explicitly when we were negotiating this service design that no more than 50 files, then we wouldn't have the problem after that. And we wouldn't have many problems after we solve this issue. Of course, you need to think, will it be possible to refactor your services? Will it be possible to add something above this existing services and so on? So you don't have to design your services at the beginning for all the cases, but you have to think, what could I do when I face this problem? So, and the second bunch of instruments, it's management, how we doing those calls. So, first thing, we might want to have retrying calls. When your call to another service is failing to whatever reason, you might want to retry. I was working for Evolution Gaming, and I was doing integrations with licensees, companies which were showing these beautiful ladies on their websites and so on. So, and some of those licensees, they specified explicitly that they money transaction service should be called, not minimum, but there should be at least 2 retries when if the first call fails. So, and they were specifying the amount of time between those retries and some other details. So, next thing is dedicated thread pools. We don't want to flood our default thread pool, which could be used anywhere in your program. We should have a really dedicated thread pool for those parallel calls to some services. We might want to limit those thread counts for each service. Even if your service B would be dead, if you define that you are going to use only 3 threads to call it, then you will have only 3 threads in your system dead, and the rest of this thread pool will be occupied with other tasks. So, background jobs, yeah, that's a tricky part, because anyway, even in the background you have to deal with problems, but the benefit of this background job is that you might work with much larger volumes, and it won't be visible to your customers or end users in a timely manner. So caching, like I said, and circuit breaker. How many of you know what the pattern circuit breaker is about? I was talking to other architects. I don't know who was that. In my company, that was only one. Okay. But anyway, still, I have a separate slide for the circuit breaker and describing how it works. You can see this is a sequence diagram and this is state diagram. So circuit breaker is a kind of class or entity or object which has only 3 states. Closed when the stream could flow through this. Current, yeah. Could flow through this. Open when stream current cannot flow through this, and half open. When the supplier that is responding properly, everything is okay. Circuit breaker is closed. Your responses, requests and responses going there and back. Everything is fine. When you got the timeout, your circuit breaker starting to count. When amount of timeouts reaching the threshold level, it closes, opens your circuit breaker, and your requests are failing immediately. So you don't have to wait for timeout. If you're throwing the request, it will fail immediately, and you will no longer need to wait for something. You can go directly to the next step of your program and say results are unavailable. So the interesting part is happening in this half-open state when some timeout set for the circuit breaker passes. It allows you to pass one single call to the supplier again. And if this one single call is failing, then from half-open state it goes again to open state, and your requests again start to fail immediately. But if you succeed with your request, if supplier service B is back to life, then circuit breaker will go and it will serve like just a proxy. Okay, I lied to you when I told that I will not mention any technologies. The best known implementation of all those principles about circuit breaker, thread pooling, and so on, it's a library called Hystrix. It's developed by a company, not big company, but quite a popular company called Netflix. So, and it is integrated in the Spring Cloud, as far as I remember, and it's widely adopted. So, I think it's worth to check it for a problem. Unfortunately, I didn't have an opportunity to use Hystrix in any of recent projects, but as soon as I will lay my hands on it, I'll come back with a story. How did we survive this Hystrix? So, trivial question how to avoid the problems. I guess I tried to compile my own small recipes for each case, and it's also quite obvious when service is not available. First, you need to. Easiest part is I was using some Java future with timeout, and the circuit breaker also could be a solution, and so on. Because especially when we are talking about internal systems, we don't have to wait 10 seconds. Like if your call isn't served within like 2 seconds, then something is wrong and we can fix it. When we are talking about third-party system, yeah, we can wait because there could be some network latencies, there could be some maintenance work on their side and so on. When services do not respond in time, again, circuit breaker and retrying calls. Because, yeah, maybe if something wasn't good, wasn't working for the first time, maybe if you retry in 3 seconds, it will be okay. But again, these recurrent calls, they are creating additional load on the system. And recently I found that in latest version of Apache HTTP client, they implemented this retrying call by themselves. And I was looking quite briefly, but I haven't found the mechanism how to switch it off. So beware of this stuff. I was using, I guess it was Rest Easy, yeah, and they were using this HTTP client from Apache, and I just got a huge stack trace and never-ending calls when service wasn't available. Yes, enormous amount of calls could be handled first by caching on your side, so you don't have to call each time when you need some data. Batch service call when you accumulating your query and then throwing it on their side and getting batch results and background processes. Yes. This is the tricky part when our calls are not served properly. In my previous organization, we faced a couple of cases when users started to complain that they have to update, in one system they have to update their documents manually. So, and we got nice nightly batch job which was pulling some data from system B. And when we started to look into it, it appeared that this batch job wasn't working for 1 year. How could that be possible? Because there was no any monitoring tool for this batch job. Statistic wasn't gathering. It was just throwing something into log file, and message wasn't clear what is happening, and nobody cared before these customers came with complaints. Also, talking about histories, they have a nice console which visualizes these statistics, calls, and is showing how much calls your third-party services has received, and so on. Yeah, and another case we got with the same job. In system A, each day users were creating like a couple of thousand documents, and in system B was designated for signing those documents through electronic channel and so on. So, and each day in system A, there were like 15 documents which never will be signed. And they were hanging, and we got this batch job, and at one day it started to fail again due to timeout, because we were trying to send update for 3,000 entities and get it back, and this update includes a lot of sophisticated logic, calling other services and so on. So, and the first and obvious solution was to kind of delete those documents which are older than a couple of months, because they never will be signed. But business told us, no, please don't do it. We cannot do anything with customer documents. And then we just split this 3,000 IDs into smaller chunks by like 15 ID in each chunk, and it started to work, but afterwards I just deleted all documents which are older than half a year without telling anyone, except you. So, the key questions. Those are the questions you should ask yourself when you are thinking that you're going to work with some service, or you're going to provide some service, or you implementing something which could be called a service. Yes. Most important question: how the human being will know that something is wrong? I guess that's the trickiest one, because also on my previous job, some people were receiving a lot of SMS about something is not working there, some problems are there, and they have to look each time into those exceptions in the log, or something was happening not correctly. But anyway, the biggest big problem were discovered only because of something stopped working for end users. So you have to design your systems understanding at which first having mechanism of escalation to end users. And there are a lot of monitoring tools. I think a lot of open source monitoring tool which allows you to write your own plugins and see in a nice dashboard what is happening in your system. And I think maybe it's a good idea to implement for your service some plugin monitoring system which you are using. Second thing you have to decide is how to decide. Don't worry, the horse is sleeping. It's not there. So yes, when you using some service, you have to decide when you can say that this service is dead or it is just sleeping. Because you have to figure out what to do with your circuit breaker or just any other mechanism. So, and then you have follow with your decision. Then you have to say that if the service won't be available, then we're going to fail all the incoming calls, or we will show to users that we cannot use the service, and so on. The key point here is that user should learn that some third-party service is dead, looking into stack trace shown him in a browser. Yes, and the third important question to ask ourselves is how to live with that service. Because, for instance, if we got 3 sub-services which we are calling from our system, and one of them is dead, are we still able to show to end users or to other systems some meaningful data, or we should decline all the incoming calls? Trivial, but some people are forgetting. Okay, I think I'm done. There is a takeaway for you: circuit breaker, caching, monitoring statistics, and balancing your calls. I mean, not only balancing, but designing your API to endure the heavy load. Because I guess RESTful API standards, they are not thinking about how to handle the load. They are thinking about the purity of the model. So, in this case, you have to think a little bit further than RESTful recommendations. This is all. Any questions?
Talking about retries, I suppose you are using also Spring or not?
Sorry?
Spring framework and side projects.
Oh.
Because for Spring there is a separate project called Spring Retry, which provides nice functionality together with all the annotations and recovery options and stuff.
Okay, somehow I missed it. Okay.
I think Highstick supports retries with annotations as well.
Yeah, history support is part of Spring Cloud Stack.
Yeah, right now. Yeah, I'm not using Spring now, and I haven't used it for quite a while, except some small parts in some projects. So, yeah, maybe. So, but as I told you, I won't be speaking about the technologies. I just mentioned history as an example. So you can use whatever you like. There is no recommendations for it except if it fits for your purposes or if it doesn't.
you don't speak about technologies, the question is about technologies. Yeah, you showed the flow diagram showing Heisler as proxy as circuit breaker, but it also is a proxy for retrying, and so it's kind of automatic way to try if we parameterize the number of times. But what we do, is there any way to automate retries for idempotent request when it's important that it should go exactly one?
Again, from evolution experience, many of merchants, they got in their services, they got transaction ID as a parameter, and we were trying with this parameter, we were generating this transaction ID, and then we were sending them with the retry. And in case if they served this request at the first time and we didn't get the response proper, or it was lost somewhere, so they were refusing the further retries. Okay, are we done with questions? Then I have a story for you about how important it is to monitor your services. Again, in 2010, I was working as a subcontractor, outsourcing for Russian insurance company, and it was quite big, top 5, maybe even top 3 in Moscow at least. And there were another insurance company from Switzerland which opened branch in Moscow, and they hired one of managers from our client, IT managers, and his kind of priority number 1 was to create IT infrastructure, put all necessary systems in place, and one and most important stuff was to have a system for insurance agents where they're typing in policies, creating new policies and selling them, and so on. And he came up with a brilliant solution. He just called his former colleagues and offered them money to steal the system from their current employer. And they put this system in place, rebranded some UI a little bit. And of course, there was no any monitoring. They were not monitor anything in this system. And the first people who smelled some trouble was insurance agents from this company I was working for. So they started to see some strange insurance policies in their system. So guys just put system to the competing company, but they haven't changed endpoint, and all new policies were sent to competitor. There was a criminal process, of course, after that, but yeah, we have to monitor our services. That's all. Thank you. Thank you.